Hello and welcome back. Today I have a huge power supply and it is from the brand Rohde Schwarz NGRE 4030. It can deliver 40 volts at 30 amps, so it's like 1200 watt linear power. It is huge. So why this weird camera angle? Well, it doesn't fit on my desk. It is almost 40 kilos, so that is like 88 US pounds. It is super heavy and it is huge, but that's because it has real transformers. It doesn't only weigh a rock, it is also built like a rock. It's a proper German product from Rohde Schwarz. I think you can run it 24 hours forever if you want. We will see when I open it later how it is built, but I expect a lot of it. Nowadays, if you want 30 amps, you probably go for a little switch mode. I think it is a kilo, 1.5 maybe. But if you work with sensitive audio equipment like amplifiers, preamps, or you're a ham radio amateur and you just don't like switch modes because it can cause distortion on your receivers, I found it second-hand and it looked like new. According to the seller, it was used for one product only. He had 3 at the time. And after that it was collecting dust. Well, if I look at it, it didn't even collect the dust either. It really looks like new. So I wonder what it looks like. But first I want to tell you about the challenges I had to overcome. A few I was already warned about, but first let's get it upstairs. So finally upstairs, and I wanted to switch it on. Guess what happened? It is a linear power supply, and I was warned about this by the seller, by the way. The seller who knows his stuff. The seller was related to a company called Amplimo. It's one of the largest in the Netherlands and maybe in Europe who produces these toroid transformers, and it is this nice triangle. So he warned me already, you need to do this and this in your power line to make sure that you don't blow your fuses, because, well, in the end, if you think about it, it's very simple. It had one or more of these inside. I haven't looked yet, but yeah, when we measure, you probably have only 1 ohm or 2, not much at least. So when you first switch it on, you have of course your AC. Before the AC resistance kicks in, let's say first half a cycle, if you are lucky, depending on where you switch it on, but in the worst case, in this 10 milliseconds, if you switch on the worst moment, you have near 300 volts, because we have 230 here, so 311 even maybe. So when you switch it on, you're easily hitting 100 amps when you switch on for a very short time. So there are a few things you can do about it. Change your fuses to 100 amps, which is of course silly because your main fuses will blow then always before. Well, you can solve this in different ways. The first thing I did, because I wanted to do it anyway, I separated my lab on a different group in my electrical system. I wanted to do that anyway, and I even, because I have a 3-phase system here, and I just balanced it through the house, but this one is on a separate one where also my induction cooker is. So I cannot take full power in my lab, which I almost never do. I use now 60 watts here when I'm cooking, but I do most of the cooking, so I know if I'm here or I'm there, so no problem there. So even if I blow my earth leakage switch, it would be not a problem, because now, before this change, if I blow a switch here, what will happen sometimes? If I blow a fuse or I just trip the earth leakage with old equipment, you sometimes just have the earth leakage. So then the house was out of internet, and my wife in the video meeting didn't like that, of course. So I changed everything. And not only a separate group, I also used different fuses. Usually here in the Netherlands you use B characteristic with 16 amps every group, and then your main fuses, at least in my house, were 25 amps, and they are C characteristics. But this sort of, it's not completely comparable, but you get the idea. It's kind of a slow blow. So instead of allowing 3 times the current, what the B characteristic does, it allows maybe 10 times, but very, very short. So using the C-type fuses, it solved my problem, but it is not a really nice solution. It is good because it's very useful not to trip your fuses all the time. But another thing is, still this transformer gets this current shock starting up, so it's not that good for the transformer. Also, the house wiring gets a really kick every time you have this 100, 200 amps going through it for a short period of time, which I also don't think is really good. And what about the power switch here? So what is the real solution? And that is the solution also that the seller and the producer of these toroid transformers gave to me was, and they sent me this document in it's in Dutch, and they say you need to put 2 NTCs just in series, don't cut the winding shorter, just put it extra just in series, and it's for between 500 to 1000, and I think both are 5, so in a total of 10 ohms, and then at least your minimum resistance is this 10 ohms. So instead of 300 amps on 1 ohm, you have only like 30 amps when it starts up, and that's a lot softer on the transformer, and it's a lot softer on your house wiring. And here I have another example of also, they just put just in the line, you put an NTC, and because it's negative temperature coefficient, it becomes warm after a while, and then the resistance will drop completely, and then it is no influence anymore. So we see here, if we take this one, this is for a steady current of 5 amps. Well, we have like 240 volts here, so times 5 amps is above 1200. So we are good here with 5 amps. And when it's warm, we have less than an ohm here, so then it just is like, it is not there anymore. Of course, I pick maybe a little bit more heavy, maybe 10D20 or something. This is what those NTCs look like. This one is maybe a little bit too strong, so I'm not sure if it heats up enough to get to its lower resistance. This is a 10D25, but yeah, the seller said it's better to have 2 of 5. Then you also have 10 ohms, but maybe it can dissipate better the heat. So either of them is fine, 2 of these or 1 of these. Depends also on the space I have within the device, because I like to put it in the device so I don't forget. But instead of using these, if you have enough space, maybe you want a soft starter. And this is a soft starter I got from AliExpress. They are in many shapes and sizes. But it actually does the same. Here we have also 2 NTCs. This is a 20D20, so this is 20 ohms and 20 ohms, but in parallel, so it's also 10 ohms in series. And then after a while it is bridged by a relay, so you don't have the heat of the NTCs, and they can cool down if you like that better. But this I cannot put in series in the connecting cable. I need to put this really in series after the switch of the device, because the timer will probably start immediately when I put power on, while this one I can put anywhere in the series circuit, if it is before the switch or after the switch, but this one needs to be after the switch. I just thought I connected and it will work, not thinking at all, because it all makes sense. I probably do the NTCs just inside, but first I like to see if I can do the big 10 ohms, or I should do the 2 5 ohms in series to also have 10, but maybe they dissipate better. And I also need to see what it does with full load, how hot do they get, and which one is then the better option. So this is it close by. It looks amazing. It's like new. The dust that you see, by the way, was dust that it was collecting here before I got the changes in my electrical system done, and before I got my parts for the NTCs and the soft starters. This one was also in an analog meter version. I like the digital because you can really set your current very precise. You have from 0 to 3 amps, that gives you an extra digit, or you go to 30 amps and then you can set it very precise, your current limit and your voltage, and the same here. Analog meters are also pretty cool. I think for little current changes you just see it faster than when the number goes up and down. But the modern look also has something, and I like the modern look. Before this one with the analog, there was even an older one. Some strong connectors here, output, even with sense wires. Well, the sense they have connected together, because otherwise we would not have output. Let's see the sides. Both sides have these huge handles, and remember it's 40 kilos or 88 US pounds. We have a nice foot here. Let's see the back. Well, I cannot rest the front on my chair, so I will do it like this. There is proper cooling here. You can see the PCBs, which are a lot. Fuse, 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 fuse. The main power, and again we have all the connectors with the sense and the output and the extra earth, and it seems that we have some extra connectors here too, or we can adjust here the over voltage protection and the current. So it seems like there is enough space if we look through here. Not sure it shows on video, but when we look, there seems to be at least 4 centimeters before the PCBs start. So we have not enough space, and it looks like there is enough cooling to put our NTCs there, just behind the connector here or behind the filter here. Whoa. Wow, this looks almost like a huge amplifier with 3 big transformers. That's why the low resistance and the high startup current. I see some really big diodes also. One huge diode here in the front. This is probably for return voltage, that it doesn't go in. Also on the heat sinks, look like big diodes. The transistors are probably here on these sides of the heat sinks. There is an electromotor. Well, each transformer seems to have at least 4 transistors, because I see one here on the heatsink, one here, and then of course we have here and here also, and here and here and here again. So if we have 30 amps, each would do 10, and then the 10 amps are done with these 4 transistors, and cooled here with this own ventilator. Here's probably also a big diode, and I think I saw some temperature switches on the back there. Looking at the back, I tried to zoom in a bit, but it seems that I can see here these thermo switches. Maybe if I pull up a little, but it's 40 kilos, we can see better the switches. Yeah, and in the front here we just see the electronic voltage current meters both. Let's see in the other side, because I haven't seen some proper caps yet. Looking at the side here, a lot of controls, probably where the current limiting voltage settings are done. These seem to be relays, so probably they can switch on and off certain transformers depending on the voltage, or they put them in parallel or not. Not sure what they do there, but it seems that it is switching the power here, the brown ones, because this is output. Okay, I said I haven't seen too many cups yet, but well, on this side clearly each well, if we say 10 amp, each 10 amp rail has like 40,000 microamps, so we have in a total 120,000. Yeah, it's a lot. not too much on this side, but we can see the big transformer. It's all put in metal with big bolts. It looks proper. The big diode here, and here we can indeed see it has 2 transistors here, and on the other side the same. So each 10 amp rail here has 4 of those. If I want to do some testing with the NTCs, I can try to connect them directly here at the power, but the power supply is now upside down. But I see this wire going here and then going to the side. And in the side we have also good access, and I can run it just with the right side up. And also there is no mesh here, so there is no cooling here in this area. Not sure I want to cool the NTCs because we want to have them low resistance, but we just need to make sure that it is sort of under control. So when I follow the wires here, these 2 wires here are the power, the white ones. So if I just cut one here, I put the NTC in between, and I will probably do it here around this area here, put some isolation, and it will be here because the ventilator, if it sucks or blows, there will be air here in this hole. So if I put it around here, it's probably okay, and I can run the power supply with the right side up. So I managed to get it on my desk anyway. So let's try to put, I will first just try the 10 ohms here. This is the 10D25, so that is one of the strongest 10 ohms I have, and then I have just one here, and we just see how hot it gets. I want to see the voltage drop, and when it is warm, what we have left of that voltage drop, and it should be close to 0. And then I will try also to put some load, of course, with my electronics load, and then we see what will happen. It's all connected. This is the input current. It cannot see the inrush, but it will see at least the basic. I want to see how much voltage drop we have here, so I try to measure that. Okay, scary. Let's plug it in. Okay, here we go. Yeah, it boots, no problem. And we have now a voltage drop of only 3 volts. And the current we have is 440 millis. And the voltage should slowly be dropping. We have now 24. That was a very smooth start. I think it's about a minute. I'm also connecting in my electronic load because I want to put some load, and we will see here then the load. First check the temperature, 30 degrees. Well, that's okay. This should drop more when it gets hotter. My current is full. I'm to 3 amps. Let me set the voltage to 10 volts. Here we have it, 1 amp, doing about 10 watts. This power supply at 10 volts 1 amp has an efficiency of 10%, which is not that good. Is it getting very hot? I don't think so. We're doing that. We can go higher, I think. 5 amps, we can see. We also get more voltage drop, but it immediately starts to get hotter, and that's why it will drop also again. Yeah, temperature is not that hot. And now the efficiency suddenly becomes better, 22%. 10 amps, we see that on the primary side it is 1.8 amps. Here we have 9 and it's 24.7% efficiency. This one drops again, so that's good. The resistance starts to adjust. Is it getting very hot? Not really, 25. That's okay. I'm going to remove this meter. At least the load I will connect directly. Then we can't see this side, but we do see this side and this side. I connected the load now directly to the power supply. We should be able to go up to 30 amps. Then I like to see what's happening. Now it's off. Voltage drop is minimum. That's good. Give me full power. Keep it to 10 volts. And now I will change the current to higher setting. 20 amps. We see now that means like 3.5. Yeah, there goes the electronic loads. This is only 200 watts. It goes to 35 degrees and then we see the voltage drop, so it only gets better. Yeah, and in the front it also says exactly that. Okay, I think you can see the display, 10 volts, 20 amps. We should be able to go to 30, so let me try 29. Here we go. 5 amps on the primary side, 29 on the secondary. We only have 1.6 volt drop here, which is good. So the resistor just corrects itself. And it's now around 35, so that's good. And we can see the ventilators, all three are blowing. Temperature still around 35, 34, 35. No problems there. We can increase the voltage a little bit. 30 volts, 29 amps. No problems here. We have now almost 8 amp on the primary and I start to smell. So yeah, the NTC starts to get warm. 50, 60 Celsius, so that is hot. We are now 850 watts of load. Let me increase the voltage a little bit more. We should go able to go to 40 volts. I switched something, I don't know what it did. Oh, we can go to 50 volts even. Cool, 50 volts, 29. And oh, something is smoking. I think we go above 10 amps. So my meter that was in between has a problem. And we are now at 1000 watts. So that was the problem probably with my meter. And I start to smell electronics. Yeah, 100 degrees for the TNC, but it should drop. That's why you probably want to have it switched off. Because now, even though it's only 1 volt of voltage drop, the thing gets bloody hot. Or it already, yeah, it's still around 100. Very local in the top. Okay, the device is cooled off. There is no damage to the NTC whatsoever. So apparently it is no problem that it gets hot and it just returns to its normal temperature also quite fast. So this could be the solution, but somehow I don't like that it gets hot at all. and especially in high power. So maybe I like better, if we try that first, this delay, the soft start. And I think the relay bridges later the NTCs and then it doesn't get hot anymore. So I like this, but I need to do this after the switch. But the good thing is all the fuses here are in the back. So the white is to the switch and I have more than 2 black ones, but there are 2 other thicker ones. These go from the switch. So yeah, in a sense I can just put it in between here and that should be enough. So I want to try that just to see what it does. And then I have this nice transparent box. The PCB fits in here. I need to cut the corners a little bit, but then it fits in the box, and the box very nicely fits in the back right here. So I think I'm gonna do that on the outside, and then we can also see with the delayed on, with the light here, that it does work. But first, let me try it just here. Okay, it is put in between, so the power goes through the 2 white ones to the switch in the front, then goes back to the black ones. Here this is AC in, AC out, goes back to the fuses and then back to all the transformers. So let's see how this works. If it indeed switches off later the NTCs, because that was the whole thing about it. We can still see the current here on the bottom, that's primary power. The NTCs are cool. You need to think of that. If you switch it off and the NTCs are hot, you need to wait until they cool down before you switch it back on. Well, with this one, it is not a problem because they don't get that hot, because it's only for the start. We can send the ammeter in the bottom. Here we see the light. I will switch the power on now. Light goes on, and I think the relay already clicked. So that means if I put load now, best check is put current to full. Do I have voltage? No. I have now 50 volts. Well, that is okay. I can do 10 amp on the electronic load. We will see here then at 10. Can we see it? And 10 amps. Go. I can hear some noise, but it indeed does it. It says 500 watts. It's 500 watts here. We have on the floor 4 amps. And it should not get hot. No, they are not hot. Let me drop the voltage because it's not made for 50 volts. Go back to 40 volts. Yeah, 40 volts, 10 amps. Let's get some more current. $20 amps, so we are on 800 watts. The LED is still on. The TNCs are cold, 26. So this is much better. I like this much better. 25 amps, we are up 1000 watts. 1000 watts. And the TNCs are cold. I like the soft start much better. Yeah, and the cool thing with the soft start is if I switch it off now, cluck, and because the TNC are cold, I can already switch it on again immediately. Switch it on, light goes on, cluck, you can hear the relay, and we are up and running again. Perfect. I was able to put it on the disc again because all the weight is in the front of the transformers. And what I like to do here, that's why I cut it so far to the front. These wires will end up here, and then I have another set here. This box fits super exact here. I can do this if I cut the corners of the PCB. There are no tracks. It fits exactly in the box. I drilled 2 holes for the cables, put some rubber there, and it is with the window, so we can have a look. I put this in the back because the power plug will stick out also, so it will be more or less the same as this. And then we have a nice box, and it doesn't go into the wind of the ventilator. So we just need to cut the corners, drill a few holes. I will do this properly with a nut and a bolt straight through. So this looks again good as it was, just solder and a little bit shrink wrap. And in the back, so now in the back we have the Softstart. Great space for it because they stick out even less with the plug. So nice position, and we can look here. We switch it on. And the light is on, and it has started. So the Softstart worked good. I got it back on the floor, put this back in its casing, ready to put it in the rack. Yeah, just to find out that it doesn't fit. While all the other equipment has ears that stick out, this one uses the full width of the ears. Because here we can see it is all straight and it doesn't go in first and then goes back. So it doesn't fit because I put it in a perfect size that most of my equipment fits. And really everything fits if we look at this. So this size was perfect for me, except if you have a Rohde Schwarz power supply. This power supply, I remember my first picture, I was so happy I found it. It was an amazing deal, so I'm happy about that. But I need to rethink where to put it because I really planned it to put it there in the rack. And yeah, I don't know where I have space. It was a challenge to get it upstairs. Then it was a challenge because I needed to change my electrical system, or at least I preferred to do that anyway because it was needed. And then with the Softstart also. So it took me a day to get it upstairs, another day to change the electricity. And now I've also been working on it all day just to play a little bit with the Softstart, and in the end these Chinese Softstarts are actually pretty good. I will leave a link if you also have some big devices or electromotors that need to be started. But it is also very smart to use the NTCs. I didn't like the cats a lot, that's why I chose the Chinese Softstart. They are a bit more expensive because these NTCs are probably less than €1, and the Softstart was 8 or 12 I think. But I just like it better. Well, that's it, my power supply. Thank you for watching, and I hope to see you next time.